So on your calendar, and what's in purple, that's what we did yesterday, and the ISM page it goes on. Then this is what we're doing today and what ISM page it goes on, so there's never any question. You are getting an assignment today, and there's the due date. All right, so anytime you ask me, you say, Miss, when's this assignment due? My answer is always, what did you write on your calendar? And if you didn't write it down, that's on you. Where can you go to find your calendar if you didn't see it or if you missed it because you were late to class or whatever? It's in Schoology. I don't think I showed y'all Schoology the other day like I was going to. You should, unless you're new to the district or something, you should be at least familiar with Schoology. What I'm going to show you is the pre-AP section, because right now they pretty much look the same, and y'all's is updated except the calendar isn't updated for today yet, but I'll fix that. I forgot to open it. But when you go to Schoology and you click on your pre-cal class, it'll say something different here, but it'll look just like this right now. When you go into the first 6 weeks folder, there is a link to the first 6 weeks playlist on YouTube. So when you click on that, it'll be every lesson that we do, because I record every single day. So if you are absent, so for instance, since you weren't here yesterday, today you can take the notes that I just gave you. You can click on this link in Schoology. It'll take you to the playlist, and you find the name of the video should match the name on the notes, and you'll just see the exact same lesson that we did in class. It'll also be the calendar here that is automatically updated with whatever I type in. And I know this says pre-AP right now, but the calendar for today is the same. We're going to do a little bit of something different in here, but the calendar looks exactly the same. Y'all's will be updated right after school once I do it. But that makes sense? And then underneath there, there isn't yet, but there will be folders that have blank copies of the notes and the homework. So if you lose your assignment, it's here. If you don't have a printer, don't print it out and do it on notebook paper. Sometimes that makes things a lot harder, but it still is at least something, right? It'll be there for you. All right, so let's look at what we're doing today. There's more review today, and we're going to look at evaluating functions. This is going on page 26 when we're done. And we're going to start by talking about explicit and implicit equations. Does that sound like something you've done before? Probably not, I would expect. You have done it. I don't know that those words were used with you, but you will know what I'm talking about once we do it. Who can tell me what just the word explicit means? Doesn't have to do anything with math necessarily, just... like very clear, right? Yeah. Okay, there you go. Or you could also have explicit lyrics, right? Somebody brought that up earlier. So those are like two different definitions of the word, but we're not worried about the explicit lyrics right now. We're talking about the explicit, stating things very clearly. So this form of the word explicit means that something is stated clearly. So in explicit equations, what those are equations that are solved for a specific variable. Okay, so equations solve for a specific variable. It's being stated clearly, it's solved for a variable, so some examples would be like y equals 2x minus 5, or y equals the cube root of x plus 3, something like that. I've solved for y. That is an explicit equation because it is solved for a variable. And notice it doesn't say solve for y, but just solve for a variable. In this case, it is y. So implicit is just the opposite of that. This would be equations not solved for a specific variable. So examples here might include x squared plus y squared equals 7, or x minus 3y equals 4, something like that. Okay, so that's the only difference between explicit and implicit equations. Solve for a variable, not solve for a variable. Easy enough? You've seen equations in both forms, right? So we're going to do these first 6 examples together, and this says write each equation explicitly in terms of y. That means we are going to solve for y. right? Basically, that's what that means. And then it also says state whether or not it is a function, because right now we're just talking about these as equations. Some of them are functions, some of them are not. For some of these, you can tell by looking at them, just by looking at what you have. For some of them, you should already have an idea of what the graph would look like, or at least what the parent function might look like. And then some of them you won't, but when you solve for y, then it'll be more obvious for you. And some of them, it's both are obvious. But so on number 1, if you were to graph that, what would that graph as? What do you think? It's linear, okay? You would get a line, right? Does that make sense? So if it's a line, is it a function? Yes. Are there any lines that are not functions? Which ones? The vertical. If you have a vertical line, it's not a function. But is this a vertical line? No, so we already know that. So we know it's a function. We got that half answered, but we still have to solve for y. So I'm going to do 2 things at once. I'm going to move my 4y over, and I'm going to move my 20 over. So it's going to give me x minus 20 equals 4y. All right. Move. You got to pass? Or you're in the restroom? Okay, so that was quite a while. From now on, if you're that late, you have to go to the office. All right. So x minus 20 equals 4y, and then is that explicitly solved for y? No, because I still got the 4, got to divide, so this is going to give me 1/4 x minus 5 equals y. All right? And then I have explicitly solved it for y. It's fine that y is on the right, and this is, yes, it's a function. Okay. We good? All right. So number 2, what is that an equation of? It is implicit. Absolutely. Very good. So it is implicit. Specifically, what is that an equation of? Circle. Okay, that is a circle. You learn the, I'm not so sure if you do those in Algebra 2 anymore, but you do them in geometry. You should at least know that it is the equation of a circle. If I graph a circle, is it a function? No, it fails the vertical line test, right? So I know it's not a function right now, but I still have to solve for y. Okay, so in order to do that, I'm going to move my x squared over. So I'm going to get y squared equals 25 minus x squared. I need to get y by itself, so what do I need to do? Square root. So I'm going to take the square root of both sides. That's going to leave me with y equals square root of 25 minus x squared. Now when I get to this point, does that become 5 minus x? Like, can I just take the square root of both of those things? No. The answer to that is no. It does not work that way. If you have more than one term, you don't just get to take the square root of each thing. So I cannot actually take the square root of it. It kind of has to stay like that. But there's still something not right about this. What's missing? Any idea? What's missing? No? What's missing from what I have? Okay, so let me ask you this. What? The square root still, that part, like it does not cancel out because there's 2 terms. If they were being multiplied, then I could, but because there's 2 terms, I can't. Like if I factor that, that factors into x minus 5 times x plus 5, and I can't actually cancel anything out. No, it does not become 5 minus x. No, it does not. You do not just take the square root of each one of them. So let me ask you this, like ignore that for just a second. If I have x squared equals 16, right? What does x equal? Plus or minus 4, right? So when you take the square root of both sides, x is equal to, it's actually plus or minus the square root of 16, so it's plus or minus 4, right? Because if I take a positive 4 and substitute it in, I get 16. If I take a negative 4 and substitute it in, I still get 16, right? So when you take the square root like that, you have to add plus or minus to it. You cannot forget that. That's hugely important. Otherwise, you only have half of your graph. Okay, if you know that that is an equation of a circle, if you leave off this plus or minus and that's all you have is the positive part, you're only getting the top half of the circle. Does that make sense to you? So that negative is what gives you the bottom half of the circle. So when you introduce that square root into anything, that's going to come up a lot. So don't miss it every single time, because some people miss it every single time. Don't be that person, right? When you take the square root, you have to put in that plus or minus. And this is kind of the why that hopefully makes it make a little bit more sense. We're good with that? So if you put it in there, you got to put that there. So that is what it is, solve for y. I cannot simplify it anymore. I need the plus or minus. It gives me both parts of my circle. And we decided way up here that no, this was not a function. Okay. All right. We all good with that? Yes, ma'am. If you factor that, 25 minus x squared is equal to 5 minus x times 5 plus x. So you can, okay, so you can factor it, but that's not going to do me any good. I still can't take the square root of it. It's like it doesn't really simplify it. It almost just makes it worse. But yeah, but it wouldn't be wrong. If you had that under there, it wouldn't be wrong because it is the same value. But this clearly is not the same as just 5 minus x if you think you can just take the square root of both of them, right? Okay, good question. Anything else? All right. So let's look at number 3. On number 3, you should have a good idea of what maybe not exactly what this graph would be because there's transformations in there, but if you think about the parent function, if it is a function, but like the parent graph of this, if you have a y squared and x is not, that is something you are familiar with, like kind of ignore the extra stuff. You also know, what if I had an x squared and y was not? Like if I have y equals x squared, what is that? It is a parabola. That is a quadratic function, right? So it looks like this. So instead, I don't have x squared and y here, right? I have x equals y squared, right? The x is not squared, the y is. So what does that graph look like? It's not a line. It's what? It's to the side. These are inverses, right? Remember doing inverses when you just switch the x and the y, right? And then you solve. So these are inverses of each other. When you have an inverse, the graph is just reflected in the line y equals x. So this is, when the y is squared, your parabola is laying down. Y'all remember doing that? When x is squared, your parabola is not laying down. It's up or down. When y is squared, it's left or right. So if that's the case, now this isn't this exact graph because then it's also transformed. But just to think of it in general what it looks like, if it's laying down, no matter where else I translate it to, is that a function? No. So I've decided now I know this is not a function. So now all I have to do is focus on how to solve for y, right? So I want to get y by itself. In order to do that, I'm going to move x over. So I get y plus 1 squared equals x plus 3. What do I need to do next to get y by itself? Square root. Good. So I'm going to take the square root of both sides. So this is going to give me y plus 1 equals, what do I write first? Yeah, plus or minus. Very good. Plus or minus the square root of x plus 3. Do I still have more I have to do? What do I have to do now? Okay, subtract the 1. Good. So y is equal to plus or minus the square root of x plus 3 minus 1. And I've already decided this is not a function. Okay, everybody good? Any questions? Because even though I decided that here, I haven't changed what it is or what the graph looks like. I've just changed what the equation looks like. It's just in a different form. Okay, any questions? Stop me if you got questions. All right, so let's look at number 4. If you just look at that, do you know what the graph looks like? Like, do you have any idea, maybe? Okay, maybe. So some of you may kind of know what it's supposed to be. Most of you probably, when you look at that with the cube root, you're like, yeah, I have no clue. That's okay right now. Like if you look at this and you don't know what it's going to be, that's totally okay. Maybe after we solve for y, it will make a little bit more sense. So let's not worry about whether or not it's a function, and we're going to solve for y. So I'm going to take this term that has the y in it and move it over, and move the 7 over. So I'm going to get 1/2 x minus 7 equals the cube root of y. Everybody with me so far? Okay, good. Now, I need to get y by itself, so what do I do to get that by itself? Cube it. The opposite of the cube root is cubing it. So I'm going to cube both sides, which means on the left, I'm going to get 1/2 x minus 7 cubed equals y. So now I have it solved for y, and this is cubed. Do you remember doing cubic graphs in Algebra 2? Okay, when you talked about some of the basic graphs you should understand. Is it a function? Yes, because it was a cubic function, right? The parent function for a cubic, because again, you should have the idea of the shape in your mind, looks like this. That's not this specific graph, but that's the parent function, right? And that's a function. All this 7 is going to do is move it. Would it move it left or right or up or down? Okay, when it's x, yeah, it's the left or right, and since this is minus, it would move it to the right, and then this 1/2 is that stretch and compression, right? So we'll get to all that later, but that still doesn't change the fact that it's a function, so your answer is yes. Okay. Everybody okay with that? Any questions? All right, so number 5. When you look at that, does it just jump out at you what the graph might look like? Okay, maybe, maybe not, right? Depending on how far you think into what's happening here. But let's solve for y. So I'm going to take this term that has the y in it. Since it's negative, I'll just move it over so I don't have to worry about signs, and I'll move the 8 over. So x minus 8 equals the square root of y plus 1. What do I need to do next? Square it. I'm going to square both sides. So I get x minus 8 squared equals y plus 1. Still got to get y by itself. So x minus 8 squared, not equals, minus 1 equals y. All right, so now that probably looks a little bit more familiar to you than the first way, or maybe they both do. What is this going to be when I graph it? It's quadratic, right? It's a parabola. When I have this parabola, remember my y equals x squared is this. This 8 does what to it? Moves it to the right, okay, because it's negative, but it's x is the liar, right? It lies, you go the opposite way. So move it to the right, 8, and then what does this do to it? 1 down, okay? But it doesn't change the fact that it's a function, so your answer is yes. Number 6. Pretty sure you're like, I don't know what the heck that graph is right now. That's okay. Let's solve for y. Now I have 2 terms that have y in them. These first 2 both have y, so I'm going to leave them right there. So xy minus 5y, I'm going to move the 1 over, equals 2x plus 1. In order to get y by itself, and it's in those 2 separate terms, what do you think I'm going to have to do? I'm not going to divide by x, because if I do, but I've got both of those y's. These 2 terms have it in common, right? So I'm going to factor it out because it is the greatest common factor. Since they both have a y in it, I can factor it out. So this y comes out here, and I'm left with x minus 5 right here. Everybody with me on what I did in y? Right? I just factored the y out of those 2 terms. That's equal to 2x plus 1. Still trying to get y by itself. What do I do to get y by itself? Divide, because this is multiplication. Opposite of multiplication is division. So y is equal to 2x plus 1 over x minus 5. So I want somebody besides Christian or this table to tell me what that thing is. Anybody? And it's okay to be wrong. Right? You did graphs that look like that in Algebra 2. You probably spent quite a bit of time on them. Can anybody tell me what it's called? Okay, it's written in a fraction, right? What's another word for a fraction mathematically? A ratio, okay? So this is written as a ratio. What kind of graphs are these? It's another form of that word. What? Anybody? What's your name, sweetheart? You need to sit up. Come on. All right. Can one of y'all tell me then? What's this called? What kind of graphs are these? Rationals. See? Is your name Christian? Oh, I meant that Christian, but yeah. I think, unless you had been answering too. Okay, good job though. It's okay. All right, so these are rationals, right? So you did rationals in Algebra 2. Now, I want to make sure you understand why they're called rationals. It's because they're written as a ratio, and a ratio is just a fraction, and ratio is just a different form of the word rational. When you did those rationals, were they functions? Yes, they were rational functions, right? That's what they were called. If I take away the denominator, isn't it just a line? So all that's happening here is it's a line that's been blown apart. The graph doesn't look like a line. But in the denominator here, we have this x equals, we have x minus 5. So when x equals 5, is there any value there? No, x can't equal 5, right? Because you're not allowed to divide by 0. So what's on your graph there at x equals 5? It could possibly be a hole, but in this case, it's not a hole. Because it's not just that one, I can't have x equals 5 for any y value. Well, it's a line. It's an asymptote. Good. It's an asymptote. So I have an asymptote there, right? None of that matters to know whether or not it's a function, but those are things that we need to know because we are going to do rationals again. So I have an asymptote there, but it is a function, and it just, the line gets blown apart and it looks all curvy. But rationals are rational functions, and so this answer is yes. Okay. Good deal. Okay, any questions? All right. Function notation. Now this is like review from algebra or pre-algebra. These statements here, hopefully, if this is brand new news to you, then I'm going to be a little bit worried. But this says explicit functions. So we were talking about explicit equations. Now we're talking specifically or explicitly about functions. Are frequently written using function notation. So if I have y equals 3x squared plus 7, right? If I have that and I want to write it as function notation, then what's the only thing that changes? Well, that's not going to change necessarily, right? What makes something when it's written, you know that it's written in function notation and not just as an equation? It's this part that changes. This 3x squared plus 7 is going to look exactly the same. This is f of x. That's what makes it's a function of x. So y is a function of x. It could be g of x, h of x, depending on what's going on, but it's f of x there, okay? So and then it says this is read as f of x. If that's brand new news to you, I'm going to be a little bit worried, right? I mean, it's okay, but f of x, you should have seen that in function notation. Okay? So now we're going to evaluate some of them. We're actually going to skip 7 and 8 because I want to spend some time on some other stuff, because I think you can handle these just fine. All right, so let's look at number 9. Don't get ahead of me here, because one of the things, and so most of you have not been on the AP track. Well, welcome to the AP track, because you're in pre-calculus. Even though it's on level, our goal is still to prepare you for calculus. So there's certain things that have to be done. That doesn't make anything harder. It just makes it a little bit more specific, okay? Meaning that your notation is important. How you do things, if you're going to get credit for it, those sorts of things that you have to make sure. And some of these things are also going to help you minimize your careless mistakes, right? If you have to substitute 4 into here, would you agree that that's something that you could do and get the right answer? Like it's really not that big of a deal? Yes? Do you mess up on easy stuff like this? Yes, you do, because you're human. I do too. I mean, I'm already messed up a couple times today on things like this. But we're all human. We're going to make mistakes. So when you do these things that I'm going to tell you are required, not because I feel like it should happen, but that's just how it should be done. And honestly, it should have been focused on in on-level classes too, but I don't think it always is. It will help you minimize those things. So if I want to evaluate P of 4, I don't just grab a calculator and punch a bunch of numbers in. I don't just start randomly writing things down or doing it in my head. Because if you can do that in your head and just know the answer already, great. Nobody cares, all right? The process is always more important than the answer. Because there's a lot of times where your process can be really good. Your final answer is wrong because you made some silly mistake up here in the top. Do you want the whole thing to be counted wrong? No. And that process along the way is what we focus on more. So to do P of 4, we're going to do P of 4 step. Always. 0 work. You substitute it in. I don't care how easy it is. I don't care how much of a genius you are. I'm going to substitute 4 in for x. So this becomes 4 plus 1 in the numerator over 2 times 4 squared plus 4 times 4. 4 times 4 minus 13. Now, I am not saying that you have to show every single little step. That is not what I'm saying. It is okay to skip steps. Some people choose to write every single step because they feel like if they don't, they're going to make mistakes. So that's up to you, and that's fine. But that first step of substituting it in, that's actually where a lot of careless mistakes happen. Because I know you know 4 plus 1 is 5, but I still don't want you writing that first. We substituted it. So then we can start cleaning it up a little bit. I know that 4 plus 1 is 5. Then when I get down here, can I multiply 2 times 4 first? No. Okay, Aunt Sally says we got to do exponents. So 4 squared is what? 16, and then 16 times 2 is 32. So that first number is 32. Then 4 times 4 is 16, and then minus 13. So I carry across my numerator here. So 16 minus 13 is 3. 3 plus 32 is 35. Can I reduce that fraction? Yes. What does it reduce to? 1/7. Good. Now, when I get here, I don't just box 1/7 and move on either. You have to make sure that you have stated what your answer is. Like, what the heck is 1/7? Well, 1/7 is P of 4. And that is what my answer looks like. Okay? Everybody okay with that? We good on that? So it's not asking too much. It's just asking you maybe to organize things. Some of you may have been doing this kind of stuff all along, whether anybody said to or not. But some of you, I think a lot of times there's just like this crazy all over the place work that we have to learn to minimize. All right, let's do 10. We're going to do g of negative 2. That's equal to negative 2 cubed plus 3 times negative 2 squared plus 7 times negative 2 minus 4. I just had this really bad feeling. Did we finish the notes yesterday? No, we didn't. And I said we'll start here, and I didn't do that, right? Okay, that's fine. We'll get there in just a minute. That just occurred to me. All right, so we're here. And when you cube a negative number, what happens? Is it positive or negative? It's negative because you'll do negative times negative, which is positive times negative, so it'll be negative in the end. Make those decisions before you start with the numbers so you don't get lost in all that stuff. So now I know this. I know it's negative. All I have to worry about is the 2. What's 2 cubed? 8. So this is negative 8, right? And then negative 2 squared is 4 times 3 is 12. 7 times negative 2 is negative 14, and then minus 4. So now when I look at this, negative 8 plus 12 is positive 4. Well, that positive 4 and negative 4 cancel each other out, so I'm just left with that negative 14. So g of negative 2 is equal to negative 14. And it's not that bad. And when you write that stuff out, instead of trying to take shortcuts that make your life harder, actually, then you're good. It's not that bad. Okay. We all okay with that? All right. Let's look at 11. So we're going to do q of negative 15. So when I substitute it in, I have the square root of 6 minus 2 times negative 15. And when I get there, what's negative 2 times negative 15? Positive 30. So it's the square root of 6 plus 30, right? Notice you have to carry your equal signs, you have to carry your square root sign, all that stuff, because your process has to make sense along the way too. So what's 30 plus 6? 36. What's the square root of 36? 6. So it's okay if I don't even write the square root of 36. That's fine. It's fine to skip some things. And the answer is 6. It's not plus or minus 6. If it was supposed to be that, then you would have a plus or minus here. You make sure you put that in when you introduce the square root sign. Does that make sense? If it's already there, you do it if it says it and not if it doesn't. Is that what you were going to ask me? All right, so number 12. P of negative 10 equals the absolute value, 1/2 times a negative 10 minus 14. Okay, so again, you can't get sloppy. You've got to carry those absolute value signs. So half of negative 10 is negative 5, right? And then negative 5 minus 14 is negative 19. What's the absolute value of negative 19? 19. And that's equal to P of negative good? All right, so let's look at 13. We're going to substitute in that 4. So f of 4 is equal to 5 times negative 3 to the 4th power. Now here's where I know you really are just like, why can't I just have a calculator? It is really not that bad at all. First thing you want to think about is when I take that negative 3 to the 4th power, is it going to be positive or negative? Positive. If you have an even exponent, it's positive. So the sign now doesn't matter at all. You can, do your little scratch work however you want, but I saw this earlier and I kind of like this. He had 4 of these written out because I'm not going to give y'all time to work it yourself because I want to make sure I have time for the other notes. But he had 4 of these written out, and then he had this because I think what he was doing was making sure he used 4 of them and didn't use more or less, so you can keep up with it. So when you do this, 3 times 3 is what? 9, and 9 times 3 is 27, and we should all be able to get to 27 pretty easily, right? We could do 3 times 9. Now the 27 times 3, some people can do in their head real quickly, some people can't. That's okay if you can't. I'm not saying you have to do everything in your head. I do think there are a lot of you that need to learn how to do things in a more efficient way. It doesn't necessarily have to be my way, but I am going to try and help train you not to freak out so much when you don't have a calculator. So if you're going to do that 27 times 3, right? You could put the 3 down here and like carry your number and do all that. That's fine. But start trying to learn how to break things up. What is 3 times 20? 60, right? What's 3 times 7? 21. And when you put those together, what do you get? 81. You didn't have to carry anything in your head either. You just split it up into like the tens place and the ones place, or think in terms of money. Makes it a whole lot easier. So 3 times 20 is 60. 3 times 7 is 21. So this becomes 81. Okay. So then, it does. So then, oh, something else. Okay. So what's 5 times 80? 400, right? What's 5 times 1? 5. So that's where you get the 405 from. And see, it really wasn't all that bad. Okay. Everybody okay with that? All right, so 14. We're going to do a of 17. That's equal to the negative cube root of 2 times 17 minus 7 plus 1. All right, so what's 2 times 17? You can do it this way, because what's 2 times 10? 2 times 10 is 20. 2 times 7 is 14. So together you get 34. 2 times 17 is 34. So we get negative cube root of 34 minus 7 plus 1. So, and then when you're doing subtraction like this, if the numbers confuse you, think in terms of money. You have $34 and have to give me $7. How much money you got left? $27. So negative cube root of 27 plus 1. What's the cube root of 27? 3, right? Because we just did that 3 times 3 times 3 over here. So that's actually going to give me a negative, because there's a negative there, plus 1. So negative 2 equals a of 17. Everybody good? All right. Let's get through 15. All right, so 15. I want f of 3y squared equals, so I'm substituting this in for x. That's 3y squared to the 3rd power plus 3y squared to the 2nd power. So when I do this, I do the numbers first. So what's 3 to the 3rd power? 27. We should know that by now, right? We did that here. We did the opposite there. We're here. So we get 27. You take a power to a power. What do you do with the numbers? You multiply them. Very good. So you get y to the 6th plus, then 3 squared is 9. Y, and then that would be y to the 4th. That's f of 3y squared. Okay. Everybody good with all that? Any questions? No, multiply. Did I say add? I don't know. Okay, multiply. I don't know what came out of my mouth. Multiply. Power to a power is multiply. Thank you. And then when you get to the 2's, whether you add or multiply, it doesn't matter because you get lucky, right? All right, so I wanted to do example 16. We might do that one tomorrow because I want to do these last 4 and then try and finish up the notes from yesterday real quick. So let's jump down here real quick. This says, using the graph to the left, find each function value. When it's asking you for the function value, what do you think it's asking you for? Well, we've got f, it's giving me f of 1, right? So it actually does not want the ordered pair, it just wants the y. Does that make sense? So f of 1, when x is 1, what is y? Close. Negative 9. Okay, negative 9. So you're just going to pull these off the graph. So do those 3 because I want to hand out this assignment, tell you something about it, and then I want to look at the notes from yesterday so we can finish those up. No, 235. All right, what did we get for f of negative 2? 0. Good. What did we get for f of 5? It's 6. I know that squares are kind of small. And what about 0? Negative 8. Good. Okay. All right, so grab the assignment real quick. Let me tell you something about that, and then I want to look at the notes from yesterday. So on here, a couple of things. You're going to see where the directions right before number 4 start, and it says give the domain and range of graphs 4, 5, and 6 in set notation. You're going to mark out set notation, and you're going to do everything in interval. Okay, no set notation, everything in interval notation. Okay. Then on the back, you're going to omit numbers 19 and 21. You don't have to do those 2. Okay? All right, everybody good? And then if you will grab your notes from yesterday, and let me see where we stopped. Okay, that's what I thought. It won't take us but a second to get that done.